Good morning, everyone. In previous lecture, we explained the concept of the plate tectonic theory, and today we are going to further explain the type of convergent plate boundaries. There are actually three types of the convergent plate boundaries. First is the oceanic convergence, then continent-oceanic convergence, and the last is the continent-continent convergence. So let's start with the oceanic convergence. It is very clear from the name that two oceanic plates going to collide with each other and created a oceanic convergent plate boundary. We know that in all type of the convergent plate boundary, the denser plate subducted beneath the less denser plate. It is clear? We know this concept. Now, in this type of the convergence, both the plates are oceanic plates, and oceanic plates are more denser than the continental plates. We know that. It's a simple thing. So, how are we going to determine that which oceanic plate is more denser than the other? If you remember the seafloor spreading theory, then you definitely knows that the older plate is a much more denser than the younger plate. So, apply that concept here. The older, the denser plate subduct under the younger and the less denser plate and created a zone of the subduction. And it also formed a deep oceanic trenches along the boundaries. Now, here is the important thing you have to remember is that the trenches formed in oceanic convergence is a much more deeper than the trenches formed in a continental oceanic convergence. One of the famous example is a Mariana Trench, which is in the Pacific Ocean, and it is the deepermost trench of the Earth. Now the next thing, in the zone of the subduction, a subducted layer transcend into the mantle, and under high temperature and pressure, it melted into a magma. And because of the high pressure and the force, the magma uplifted into upward direction and erupt into volcanic eruption in ocean floor. This process continued for a million of years, and it formed a layer over layer and also formed a volcanic islands or volcanic mountains. So that's how the volcanic island arcs formed due to the oceanic convergence. Now there is a one doubt here, or you can say one question that should came in our mind. That is, why there is a volcanic island arcs formed when there is oceanic convergence, but when there is a mid-oceanic ridges, there is no volcanic island arcs? Why? In both the processes, magma continue flow out, right? Then why there is no volcanic islands in mid-oceanic ridges? The answer is very simple. Whenever the divergent boundaries, mid-oceanic ridges occur, the magma flow out is a basaltic. And in basaltic magma, there is a less silica and they are the less viscous. So they travel a long distance and spread throughout the ocean. On the other hand, in a convergent boundaries, the magma flow out is a acidic magma. And acidic magma has a more silica and they are more viscous. So they don't travel much and solidify faster. And it also helps to create a layer over layer of the rocks, and eventually they form into volcanic island arcs. Now it's clear for you guys that why there is a volcanic island arcs in a convergent boundaries, but in a divergent boundaries there is no volcanic island arcs. I'm going to give you a few examples. First one is a Philippine island arc. In Philippine island arc, the plate involves in a Philippine sea plate and Sunda plate, and Philippine sea plate subducted under the Sunda plate. In Indonesian archipelago, it is a Indo-Australian plate subducted under the Sunda plate. And then Japanese island arcs, it is actually an important point because it is a triple junction of the plates. So the three plates which involves are Eurasian plate, Philippines plate, and the Pacific plate. And also there's one more thing you have to remember about the Mariana Trenches. The plates involved in Mariana Trench is the Pacific plate and Mariana plate. So Pacific plate subducted under the Mariana plate and formed the Mariana Trench and Mariana Island arcs. Today I covered the oceanic convergence, and in other two lectures I am going to cover the other two type of convergent plate boundaries. because it's easier to understand the one concept at a one time. And also, please comment your doubts and feedback in the comment section. It is really important for me. Until then, stay tuned and stay curious.